Hey math fans! Welcome to Math Olympiad Academy, your trusted space for advanced problem solving, logical reasoning. We would like to thank our subscribers and all viewers for their continued support. In Lesson 17, we discover another problem-solving challenge that appears simple, but tricks many students. A subtle-looking limit, solved through a systematic, step-by-step approach. Through this problem, let us consider this expression. Y equals 2 times x plus 5 divided by the quantity 2 times x minus 1, all raised to the power x plus 3. The question is, can you determine the limit of y as x approaches positive infinity? Lesson objective. We aim to find the limit of y as x approaches positive infinity using the skills and properties you've developed through previous problem-solving practice. Before we solve, let's rewrite the expression for y in this first step. After that, many students ask, where should we begin? Yes, the best place to start is by simplifying the fraction inside the parentheses. 2 times x plus 5. Divided by the quantity 2 times x minus 1. To do this, we rewrite the numerator by adding and subtracting 1 in a clever way. Specifically, we express 2 times x plus 5 as 2 times x minus 1 plus 6. This gives us the quantity 2 times x minus 1 plus 6 all over 2 times x minus 1. Now we split the fraction into two parts. 1 plus 6 divided by the quantity 2 times x minus 1. So the entire base becomes 1 plus the fraction 6 over 2 times x minus 1. Now let's look at the fraction 6 over the quantity 2 times x minus 1. Our new goal here is to remove the coefficient 2 that's attached to x in the denominator. This will help us reach the canonical form we need for evaluating the limit. To do this, we divide both the numerator and the denominator by 2. This gives us 1 plus 3 divided by the quantity x minus 0.5. Now, raising both sides to the power x plus 3, we obtain y equals the quantity 1 plus 3 divided by the quantity x minus 0.5. All raised to the power x plus 3. Now, let us make a change of variable. Let u equal x minus 0.5. This implies that x equals u plus 0.5. As x approaches positive infinity, u also approaches positive infinity. This substitution allows us to rewrite y in an equivalent form. Recall that y is 2 times x plus 5 divided by the quantity 2 times x minus 1, all raised to the power x plus 3. We've already shown this is equal to 1 plus 3 divided by the quantity x minus 0.5, all raised to the power x plus 3. Now, using our new variable u, this becomes the quantity 1 plus 3 over u. All raised to the power u plus 3.5. Using the product of powers rule, this gives us y equals the quantity 1 plus 3 over u, all raised to the power u, times the quantity 1 plus 3 over u, all raised to the power 3.5. At this step, let's move to computing the limit of each factor. We know that the quantity 1 plus 3 over u, all raised to the power u, approaches e to the power 3 as u goes to positive infinity. Students can see a detailed explanation of this key limit in Math Olympiad Academy, MOA Lesson 10. On the other hand, consider the second factor, the quantity 1 plus 3 over u, all raised to the power 3.5. As u approaches positive infinity, the fraction 3 over u approaches 0. Therefore, the base approaches 1, and the entire expression approaches 1 raised to the power 3.5, which is simply 1. So, the limit of y as x approaches positive infinity is e to the power 3, times 1, which equals e to the power 3. Therefore, the limit of y as x approaches positive infinity is e cubed. Now, let's verify the accuracy of our calculation. Let x equal 10 to the power 6. Then the expression for y becomes 2 times 10 to the 6 plus 5 divided by the quantity 2 times 10 to the 6 minus 1, all raised to the power 10 to the 6 plus 3. Numerically, this evaluates to approximately 20.085567. On the other hand, the value of e to the power 3 is approximately 20.085536. Hence, at x equals 10 to the 6, the expression for y is extremely close to e cubed. Taking into account that the relative error of our calculation is just about 1.5 parts per million, this confirms that our analytical result is correct. I hope you enjoyed this step-by-step solution. Keep practicing, share this lesson with your friends, and don't forget to subscribe to Math Olympiad Academy for more exciting math challenges. See you in the next lesson!